So first of all, thanks Makoto for hosting this. This is super cool. It was very fun and interesting working with you because actually your project was like the first application of this stuff that we kind of put together the building blocks of, but we never actually got to like see something like through in terms of like a full end-to-end application. So this was really cool. And I'm glad for all the good feedback it's been getting so far and really excited to keep this going. I did prepare some slides so I can share them.
Yeah, I think let me just add you to, I think, co-host so that you can now share. Yeah.
Yeah. Okay. Perfect. Okay. So first of all, I guess a little intro. I'm Rahul. I was based in San Francisco for a long time, but I recently moved to Europe and now I live in Amsterdam. I've recently left Amsterdam for the past month and I'm living in Madeira in Portugal to kind of, escape some lockdowns and get some sun a little bit. So yeah. And I am one of the co-founders and the CTO of Connext. So we have been building and working with state channel systems for a very long time. We started out with Spank Chain, which is like one of the OG state channels implementations. That was kind of our like incubation process. Then we broke out of that, kind of productized the state channel payment system on its own. Then we like rewrote the protocol from the ground up with counterfactual. We basically like use counterfactual as the base and sort of implemented like the application layer on top and productize and, push into production again. Our thing has always been to like work on the product side, make use of the research that's coming in, but we actually want to like deliver the end products to users, talk to the users, get the real world usage from the things. And recently, actually within the last 6 months or so, we broke away from the like counterfactual. I don't know if you guys know the story, but counterfactual basically kind of disbanded their own state channel framework and started a new one from scratch, which is called state channels. And that was like far from production ready, which they have some great ideas, but in the end, it was too far from production. So what we ended up doing is basically taking all the ideas that we'd amassed together from all these years of like deploying state channel systems into production and writing our own state channel protocol from the ground up, which takes a lot of the ideas and also takes some things that were like too generalized in some of these generalized frameworks and basically squeezes them down into really only the use cases we support, which are mainly conditional transfers. So like we don't do like turn-based games and things like that. We do like lock money in a transfer, unlock based on these conditions. And we think that on its own is a powerful enough concept to basically deal with anything that we have to deal with. So with that said, I will walk through some of the slides I prepared here. Can everyone see this okay?
Yeah, it looks good.
Okay, cool. So just a little 101 primer. I don't know how familiar the audience is with state channels. So of course, feel free to jump in. Like Makoto said, we can keep this very interactive. So if there's any questions, anything that needs clarification. But okay, so anyway, at the very basic level, a state channel is kind of constructed like this. There is a channel contract on chain, which is basically a multi-sig. And this contains like participant addresses for Alice and Bob. So Alice can deposit some money into this on-chain contract, and then she can actually send signed messages to Bob, which are essentially like receipts that Bob then can take on chain and use to withdraw the funds. And the key is that like all these signed messages off chain can happen anytime. They can be totally off chain. And then the funds can be withdrawn anytime on chain. And this is the key part of state channels is that they inherit the full security of layer one. So it's not like a side chain or something like that. It doesn't have its own validator set. It's more akin to the security that rollups provide, where the full L1 security is available. Yeah, there's of course like an adjudication, the whole system security. I'm skipping over that part. We can get into that more if needed, but that's kind of like a full discussion on its own. But it's based on a fraud-proof based system. So like, if Alice is committing fraud and she's like, no, I want to send you an I want to use an old message on chain, which says that I didn't send you the last few payments, then Bob can be like, no, well, I actually have this here to show you that that's not the case. So then Bob can go and show the latest signed message with the nonce, which overrides that. Okay, so jumping right into a more complex construction of how the actual transfers work with when there is a router involved and multiple chains. So same basic idea applies. Now Alice and Bob both have channels with this router who is basically an automated version of an Alice or a Bob with special logic to forward transfers. So now Alice can do the same thing, deposit into the on-chain multisig, can now create a transfer using a lock hash, which is a hashed pre-image. So just like a hash string. So you put in a hash of this string and you send it in the transfer. Then Alice can specify using metadata that Alice wants this transfer to be sent to Bob. The router will receive that information, then it will send its own transfer to Bob. And the kind of big key here is that the router is putting up its own funds here to lock them up and send them to Bob. So the router is currently like out of money, but there are other incentives in place to make this the case that the router actually wants to forward the transfer, such as like fees. So the router will collect some small fee for forwarding this transfer to Bob. Then Bob will eventually get the pre-image somehow from Alice. It can get him anyway. You know, Alice can go with a piece of paper and give the pre-image to Bob. Bob will reveal the pre-image that hashes to this lock hash and then unlock the funds with the router. And then now the router has the secret which unlocks the funds because this lock hash is the same. And the one big key here is both of these multi-sig contracts can be on different chains. It doesn't matter what chain it's on, as long as the funds are basically locked up here and locked up here. And the locked up funds here correspond to this deposit on this chain. And the transfer basically is locked using the same pre-image on both chains. So really, it's like, it doesn't matter. This can be an EVM chain. It can be a non-EVM chain. It just has to have the necessary like logic to dispute and send the functions on chain. So far, so good. Okay, so now to kind of jump into something a little different. The reason I'm showing this is because, you know, at Connext, we've really, like I said, prioritized like product-based things and really getting it in the hands of users. So from the very start, we've always prioritized browser-based infrastructure. Like we want this stuff to work in the browser. We know users don't want to run like nodes on their computers. They want to like do things in a browser. So we've basically come up with a construction that allows all of our whole system to run securely within a browser. And a lot of this is based using this IFrame technology. So basically within a dApp, like let's say there's a dApp called off L1 and it's running a Connext client. What actually happens is this Connext client is going to call to this iframe, which is also sitting within the same window of the dApp. But the key is this iframe is the one that is in charge of all the like.
I'm actually in the middle of meeting. Yeah.
Can you mute Makoto?
Sure. Okay, thank you. Yeah. Yeah, bye.
Okay. Okay, everyone still hear me? Okay. So this client in the iframe is a smart client. So we call this a smart client because this client has access to channel storage, private keys, and manages the full communication with like the messaging server and essentially all the backend processes. Anytime the Connext client, which is sitting in the dApp, wants to do something to make like calls, like such as create, transfer, deposit, withdraw, anything like that, those are all JSON RPC requests, which get translated through the post message API, which is a very like light API, which is the only way that Windows can communicate with iframes through a post message API. So it will send a message, the smart client will receive the message, will do all the necessary stuff, pull from the storage, interact with the private key, use WebSockets to communicate with the router, do all this other kind of stuff that it needs to do, and then it will relay responses back to the dumb client. So, you know, the RPC basically acts like as if it's calling the function on this client, but it's actually calling it through an iframe. Another cool thing about this is this hosted iframe, wallet.connext.network, has storage that can be put in any dApp. So you can create your channel on off L1, you can put some funds in it, do some things with it, but then you can also use another app that has access to the exact same channel and can do some other stuff with it. So it's kind of like it's almost like an in-browser wallet that goes around from place to place. So more or less, this is kind of like how MetaMask works in terms of it being an extension, except it's not an extension. So this is our stopgap solution until we get our browser node into something like MetaMask. Cool. So then another interesting thing that we've implemented is this thing called a withdrawal helper. So let's say Alice at the end wants to withdraw her funds out of the channel. When I say withdraw, what I mean is the funds are locked up in the channel and she wants to take them out of the channel back onto the chain. So what that requires is Alice has to tell Bob that she wants to withdraw. Bob, in this case, is the router. Router says, okay, sure, here's my SIG. So then signs it. So then now both Alice and Bob have a signed copy of this withdrawal commitment. Now, any of them, either of them, in this case, let's say Bob, because since Bob is the router, Bob takes this withdrawal commitment, puts it on chain. And this withdrawal commitment calls this function on the multi-sig called withdraw. And withdraw has some data and signatures from both of them. And the withdraw data has these two fields called call to and call data, which means if these fields exist, it can call something else atomically. So it will call a transaction on chain, basically like a meta transaction. So if we have another contract on chain, which implements this interface, this withdrawal helper interface, the multi-sig in the same transaction to withdraw the funds out of the channel, it can actually call some other helper function on chain. So this becomes a powerful construction that we can see later. I know Makoto has another diagram, I think, of this off L1, but I kind of wanted to show how we put all these puzzle pieces together. So we have a user here, and then they have a browser, and then within their browser will create channels with the router on both chain A and chain B. Let's say chain Matic and chain BSC. So then when the user comes in, the user say wants to conditional transfer from one chain to another chain. So they will call this conditional transfer function. And the key part here that I want you guys to see is that recipient is node.public identifier, which is the same as the sender. So you're sending the funds to yourself. You're just sending them to a different channel on your same browser that you have. So you have the secret to unlock this. You're just sending the funds between one channel to another channel. And then when you unlock the funds, you can withdraw them onto the other chain with the secret that you already have, because you created the secret, you sent the funds. It doesn't matter. You don't have to keep the secret from yourself because it's all within your same browser. Then also the thing that we do is we use this withdrawal helper construction to call a Uniswap API. So what we did is we created a withdrawal helper that implements this same withdrawal helper interface, but it calls Uniswap swap functions. So now I can withdraw on channel A to the withdrawal helper, which swaps the functions, swaps some tokens here, puts them back in the channel. Then I can do a conditional transfer from channel A to channel B. Then I can withdraw on channel B using another withdrawal helper that's deployed already on BSC. Then I can do some other swap here. And then finally, I can do another withdraw at the end, which withdraws out of the channel back off chain. And we've done essentially 2 swaps and a withdraw. And the cool thing here is that the user only has to interact and do something the first time they deposit funds into the channel. So their MetaMask will pop up one time to deposit the initial funds, then everything else will happen within the browser nodes and the router. So essentially it'll all be happening behind the scenes as what we saw in Makoto's demo. Then just wanted to give a little idea of what our roadmap is from here. We want to basically deploy on all chains and L2s because, you know, that's just easy to do. We support EVM. So anything that's EVM is we just literally deploy our contracts there and our stuff works there. We've also built a cross-chain swap widget, which I didn't show here, but basically does some of this stuff. It'll do this stuff all automatically within like a widget that can just be implemented into a dApp. It's like a React NPM package right now. So you can just use the React component and already implement cross-chain swaps. We're also working on a way to kind of network the liquidity between routers. So, you know, routers can have an auction mechanism so that somebody wants to, you know, here, let's say you want to transfer from this amount of money from chain, whatever, chain Matic to chain BSC in this asset to this asset. Then you can basically broadcast that out and then all these routers will be like, oh, okay, like let me do that. And then they'll all have a little like mini auction, whoever has liquidity for it, and then they will come back and somebody will fulfill your request essentially. So another big thing that I mentioned before is how the router has to front money for the transactions. So because of this construction, it means that the liquidity providers are the same people that run the routers. It's kind of like how a ETH2 node is. You have to put the money up and you have to run the thing here. But unlike the ETH2 node, this requires considerably more liquidity if you want to like scale up your operation. So we are doing a lot of research on ways to delegate the liquidity and allow external people to come in and be liquidity providers, but it's not an easy problem and nobody has solved this yet in terms of state channels. And then the last part is right now we want to get to a fully decentralized network. We are currently hosting a messaging server, which is like a global messaging server that uses the NATS protocol, while we kind of wait for decentralized solutions to become at the point where they compete with these. We've been looking into Status's Waku. They've kind of reached out to us a few times now and are excited for us to work with them. So anyways, that's it. I posted some links here. I can share these slides. Anything else? It looks like we maybe have some questions. Have you looked into Interledger protocol? James said. I believe we've looked into it a while ago. I can't tell you anything about how it would fit into this, but I will say that, yeah, things are kind of trying to standardize around this. So I think it does make sense for us to look in and make sure that we are following, adopting, creating standards around this stuff. But cool, that's all I have. So
yeah, I have a couple of questions. There's like, we had a chat about the Seller released a new one and something similar, and Chris from the Ethereum guys also mentioned about Hop.
right.
Can you explain difference of these different ones?
So yeah, we've worked with Seller over the years. We've collaborated with them many times. They have always been targeting sort of a very different use case in terms of the gaming stuff and Go-based clients and things like that, while we have kind of focused on the browser-based infrastructure and doing like conditional-based transfers. I have seen that they have started to look into this stuff. I know this is in response to kind of what we've put out and the response we're getting. So, we'll see what they put out when they put it out. I don't think they put out their widget yet. They said that their UI is coming, but we will be keeping an eye on it. As for Hop is doing a really cool thing with the lower level infrastructure. They're basically making these like bridge infrastructures lower level they're standardizing the way to like go roll up to roll up, like through their bridge infrastructure. And then if you read their white paper, it actually talks about this bonder. So the bonder mechanism is somebody who fronts the liquidity in order to facilitate the quick swap. So that construction is very much like how our router works. That's kind of like hidden in their white paper, but if you look at it, they have a section in the white paper that basically describes exactly what a Connext router is. And they have their AMM thing is actually within a chain to go from a token to like a hop representation of that same token. So basically go from like die to hop die on rollup A, then you go through their bridge, then you go die to hop die on rollup B. And you have AMMs here and AMMs here, but you don't have the AMM in the middle between the two chains. So that's kind of the big key that's missing, is the like AMM liquidity mechanism between the two chains. And that's what, you know, people like Thorchain and stuff like that are working towards that. But again, like Thorchain, if I had to compare those, would be like a proof of stake based solution that, you know, again, has its own validator set, doesn't use the full L1 layer 1 security the way that we do.
I think James asked, how we look into Web3 API? Did you answer this one?
Web3 API,
Yeah.
last I looked, they were something like Graph. I did not know that they have something else.
Yeah, I thought so. I thought it was more.
Yeah.
No, I thought it's more like chaining, maybe. I don't know.
Yeah, like
running things in the browser. And so when you're saying, you know, browser based, they have a mechanism through WASM so you can run arbitrary code in the browser in a more decentralized way.
Okay. I will look into that a little more then and see if it fits in.
By the way, James is ex-Bankchain, and he had his own state channel framework for a bridge. So like, you know, you see lots of pros in this. Yeah, meetup.
We've worked together way back in the day.
And, at Spankchain, actually. So it was the kind of first, I don't know, what would you say, Harold, the first incarnation or like or something?
Yeah, we were the state channel OGs back in the day.
Yeah,
but cool to see you again. It's been a while.
This is great. This is amazing. You guys have been just on it for a long time, and it's exciting to see where it's come from. And now market timing can be better, I think.
Yeah, it seems like, you know, a lot of people, like state channels are getting kind of written off compared to like roll-ups and stuff like that. But it seems like there is this like niche use case, especially as this multi-chain stuff has been blowing up, that it actually does seem to work pretty well for. So
have you explored non-EVM chains?
We have, but I mean, the what would be required to deploy on a non-EVM chain would essentially be to port all of our Solidity contracts, which the majority of is like the adjudication layer, into that, and also like write an adapter for the like Ethers based like Web3 service. So we haven't gone all in on that yet because, you know, we were going to do it with some kind of ZK roll up, but now it looks like ZK Sync is even trying to go EVM. So if they do that, we won't really need to. But yeah, I mean, it's just bandwidth. And right now we don't have the bandwidth to do non-EVM.
Yeah.
Like to one day.
Yeah, no, understood. I mean, you guys have done a great job so far with limited resources and just, you know, innovating.
Yeah, appreciate that.
Do anyone else have more questions? Or being shy? Or one question is how do you do the kind of maybe I will just present what I've done, and I have a shitloads of questions maybe, so I can just fire off. So totally. Yeah, I'll just.
Okay, I can stop my share.
Oh, and by the way, if anyone is working on this area and if you want to show off, you can do that. Like we still have like 25 minutes and the stuff. So if you like, I think there's a couple guys from One Hive. So if you guys have, do you guys have anything to show, or is it kind of still secret on the? Yeah.
May I ask something?
Sure.
Is this specific to ERC20 or is this more general message passing? How is that?
I guess it could work outside of ERC20, but right now, like ERC20 is pretty heavily woven into like the contracts and stuff like that, especially at the like adjudication layer. So like if you dispute something, then it has to like go through a process where in the end it will do like an ERC20 transfer if it needs to.
Okay.
So I guess depending on what the use case would be, it can scale out of that, but I think I'd have to like learn a little more about what you're thinking about there.
And then
I wonder.
Go on, sorry.
I wonder if it could take advantage of ERC 777 because at Superfluid they have this super token, which is a superset of ERC 777, and since here you're also working with callbacks, it seems, so this withdrawal helper, maybe that could simplify some things if the token is not just ERC20 but 777 compliant.
Oh, interesting. Yeah, I would love to look at like, you know, some of those wrappers on top of ERC20 because, you know, ERC20 sucks. So would love to learn a little more. I've actually recently just started looking at Superfluid. It came across my radar. So it looks really exciting. I want to dive in a little deeper.
Yeah, because what I find interesting is on these L2s, etc. So for tokens which are not yet deployed, it's also an option to have them being native super tokens. So instead of deploying ERC20 there, it's an option to already deploy it as a more powerful token. And I guess they could then also be connected this way.
Cool. Okay, well, you know, love to chat more about some of that stuff.
Well, one thought about ERC 721, I thought you can't do it because you need a kind of counterpart, a liquidity counterpart, right? And the 721 is non-liquid, so I don't think you can do like Kitty 721 when it goes from one chain to another, which, you know, there's nothing in collateral. So I think it would be harder by nature of, you know, the non-fungible.
Yeah, the key is that we can't do like a mint and burn type thing. So we need like things to be mapped one-to-one on both chains already before we start. But I guess the cool thing is like we can kind of, like it doesn't really matter to the router what the like mapping of the assets is. It doesn't care if it's like DAI on one side and USDC on the other. All it needs is like a configuration to say that those are one-to-one mapped, and then it can just like swap them instantly. And you know, you could do other things that we haven't explored fully yet, but like, you know, you could have the router be an exchange itself. So it can say, you know, it can exchange DAI for ETH on Crosschain, and you wouldn't, you know, need the AMM type situation, but it requires the liquidity in both sides.
I think that 721 might be a little bit more difficult for like dispute resolution.
Right.
Because like if you're like, I want that back, and it's because it's non-fungible. Like, how do you have that equivalent if like, you know?
Yeah, I mean, I guess you could do it if you have like it equally represented on both chains. You have like a, you know, a kitty on Matic and a kitty on BSC, then you could do that. But I don't think it's that valuable then, really. So
basically, you need to mirror, like you have some similar representative, and then once you agree that they are always the same, fine. But yeah, in case of bridge, I think the difference is something like I have a little knowledge, but like for example, if it's XDAI, they automatically, whatever you pass, they kind of automatically, you know, mint whatever stuff. So it's your responsibility to find out what that is. And in case of XDAI, I think you can ask to the token itself what's a counterpart. So you don't have to be paranoid about what's a counterpart because it's written in a contract. Whereas in this approach, actually it could be the flexibility in the sense of benefit, but it could be the attack vector or security that if you make a mistake of the mapping on one chain to another, like you less likely to do that on the AMM because only the first person, you know, when you create the liquidity for the first time, you could screw up. But after that, you just topping up the same thing. Was well, actually same thing for this one as well. But like, if you make the configuration mistake, you could just exploit it immediately. So let's say it's because the router has to have the mapping of this one on XDAI and this one on Matic can be exchangeable. If you put the wrong configuration, then suddenly like everybody try to like drain it. Whereas in something like XDAI, I don't think it can't happen because they automatically maps, I think.
But by the way, in case of XDAI, it even goes further. The omnibridge of XDAI not only knows what the contract address is on the other side, it goes as far as if you send a token which doesn't yet exist on the other side, then the bridge itself deploys the token contract on the other side.
Yeah.
Interesting.
It's kind of different trade-off, I think. Yeah. Okay. Yep.
And a router, can one router connect more than two chains, more than two parties? So it's up to the individual router to decide which token contracts on which networks it trusts, right?
Yeah, exactly. It's the only thing with the router is it needs the liquidity for whatever it wants to support. So it can support anything on any chain as long as it has the tokens there to front the exchange.
And how does the application know, how is discovery of a router which supports the transfer which is wanted?
Right now we have like hard-coded mappings of routers into applications essentially. But eventually, like I said, we're going to have some kind of like auction mechanism where, you broadcast what kind of swap you want to do, and then routers will be able to like tell you. The discovery happens basically because everything is using the same messaging server and messaging format. So you could put out a message once you're on this messaging server and you know how to, ask for routers and things like that.
Cool. Now I'll just try to do the quick demo of what I've done, and that kind of, we can continue the Q&A. So I'll share, but just a disclaimer that my demo will probably break. We just tried this morning, and I think, there is some upgrade on the Connext side, and there is something not quite working, but I think it can show the kind of flavor of it. Can you guys see my screen? Yeah, okay.
Yes.
Yeah. Okay, so this one is basically, for last couple of hackathon, I've been exploring the idea of like kind of cross-chain arbitrage. So I created a couple of visualization of like price difference of the different AMM between like layer 1 Uniswap and the HoneySwap on XDAI, or that I did. And then like in the East Global Hackathon, which just finished, I was doing for the Matic Ethereum for the quick swap and the Uniswap. And it was just visualization, but I didn't bother doing the arbitrage because we know like a bridge cost is too expensive. Then I think I got to know about Connext, so I saw like, let's see if we can do it in between layer 2s. And it's pretty much cooperation between me and Raul. Like he was helping me pretty much every day, and I was just like coding as he tells me, basically. And he also like pushed lots of code.
We didn't have docs, so it was kind of like a live docs.
By the way, I think I won some of the prize on the hackathon, so thank you very much. Nice. So on the top page, it just basically shows you the price difference of the all three exchanges. This one has a.
Is that legit? The Pancake swap?
Pancake is their index is out of sync. Like their subgraph is very, very out of sync for last week.
Those are pretty good arbitrage opportunities.
So, and if I look into USDT, it says 55, so it's not too much. But if I go to swap, this is when, so previous data I was just using subgraph, and it's because it's out of date, it's not accurate. But now I can see that, so this is a USDC on QuickSwap on Matic, And what I'm going to do is that I'm going to swap it. What I was doing, not working anymore, is first we swap USDC on USDT on quick swap. And after you swap it, you pass it from Matic to BSC. Then we go to Pancake swap and it swap from USDT to USDC. And currently I'm all connected to XDAI, so it just doesn't show anything, I think. So let me just switch to.
You took videos of this, right? Yeah, you
Yeah.
posted them. So
Yeah, so there's a photo evidence of it was working at some
yeah,
point.
don't you know you're never supposed to do live demos?
Yeah. Yeah, so like but like so now this is oh yeah, because now I have to switch the wallet as well. There you go. I have 285. I thought it's ETH, but it's just a Matic, which is like 10 cents and stuff. So I don't have that much money. Yeah, so you can see I'm basically connecting to both channels, and so it has like certain amount, and if you do like 0.1 or something, it calculates basically the price from 1 USDC to 0.1 to 0. This one is like probably if I do 10, maybe I can see a bit more. Yeah. Currently, it's not really making any arbitrage. Let me switch. Let me do. No, I'm not making any money right now. It was making some money, but not anymore. But let me just switch back. And by the way, I'm currently connected to Matic, so let me try. And also, what you can see is like you can see the swap limit. So this is a amount which has in a router. So you can on the other end. So I'm currently Matic. So there's a £5 in the router on the BSC. So I can do up to that, and a bunch of disclaimer. And so I know I'm gonna lose this, so I just gonna do this, and so it just shows you how much I'm gonna lose it. And but I'll just show the gist of what it works. Is like once when I try to click it, basically what this does is it's trying to send the funds to in the browser node.
This is sending funds to the channel contract. So that is the like channel between you and the router on Matic.
Yeah. And if I do confirm, and this morning I just changed the UI, so it just shows you step by step. And first what it does now, it's get confirmed on a MetaMask.
Can you open up the browser console? Let's see if there's anything cool in there.
Question is, can you read? I think So currently it's stuck. Yeah, it's stuck on the.
Yeah, I guess the issue is we added fees like recently, and Makoto's router got updated, and we didn't account for it in the code somehow. So this broke like today or yesterday. So
yeah, but I think something else is also breaking, because what it does is first. Let me also show you now my diagram. Now people got the base diagram, right? So let me. This one took like a while to draw as well, but so in the code it literally says Bob. Browser channel is Bob and the router is Alice, I think, something like that.
I can explain that a little bit. So basically we kind of unbalanced our channel code. So the reason for that is we have one user in the channel who is Alice and one user who is Bob. And we are making assumption that the Alice user is like a high fidelity user who is always online. And the Bob user is somebody who maybe is not online so much, like a browser user. So Bob, the cool thing is that Bob can send funds to the channel without needing to call a contract function. So Bob can just send funds to this channel address like what you did, just do a transfer, and then can reconcile them later off chain when he comes online. So what that means is you can do something like you can set up Wire to like send funds to your channel address. Then next time you log into your wallet, your funds will just be accessible off chain. So that was like a big thing that we've like from talking to users and being live with users, we've noticed that a lot of people want this functionality and they want to be able to like use their channel address like a wallet. So that's kind of how we did it. And Alice is always the router because Alice doesn't need to deposit while Bob is offline. Alice can wait for Bob to come online and then ask Bob's signature to deposit, essentially.
Yeah.
So basically Alice and Bob are like hard coded within our channels themselves.
Yeah. Then I think what we did is halfway through that first it says starting swap is like you put into deposit, and so slightly counterintuitive is withdraw is actually the act of going to the chain, and then you swap. So like now I can see the transaction. The one thing is like I am so my token is starting 0x583, but interesting thing is when you see the transaction of someone who did the swap, it's actually not me. It's basically the Bob, right? The browser node. So one other unique thing is once you
no, the one who did the swap is the withdrawal helper.
Yeah, so helper did it. So it's not the, if you look at the Etherscan, it doesn't see my address. It's the
yeah, so like that whole, the way that like meta transaction works is you withdraw funds, you send funds out of the channel to the withdrawal helper, then the withdrawal helper will execute that code. So you can do all these swaps without even needing approvals, because the approval happens, like you notice how you didn't need to approve anything like that, because you send the funds, then the funds send the funds to the channel, then the funds get withdrawn to the withdrawal helper, then the withdrawal helper has control of the funds. So the withdrawal helper calls approve on the Uniswap router, and then calls like the swap function on the Uniswap. So then you never have to actually do that approve, because then the funds come back, then the withdrawal, then the funds. Okay, the other thing is the withdrawal helper will withdraw the funds with a swap, and then it will specify the channel address again. So it's like channel address, withdrawal helper, Uniswap, back to channel address, then the funds go back into the channel off chain. It's a little crazy, but
one thing I thought is, I guess this is one way of just like more of the meta transaction, but does it lead for, it's not as hard-coded as smart contract logic itself, that isn't so every time I do the deposit and the withdraw, it's a JavaScript, which is like, calling that function, right? So I don't pre-code that. I happen to pre-code all this logic. I go to this point A, B, do smart contract, then transfer. But only the thing which has a kind of conditional on-chain logic is the kind of conditional transfer, that you only transfer this much when that happens. But before that withdraw stage, if front-end engineer have a choice not to call the Uniswap helper at all, right? Or like not call at all. So my worry or concern is that before, every time you click yes on the MetaMask, you are kind of approving to do certain acts, which not necessarily that everybody knows that what that is by just clicking it, but at least like that's kind of you asking approval. But now, like once you send a fund, JavaScript can do whatever you want, right?
Yeah.
So can they do completely something completely like you didn't approve?
Right. I guess what you're getting at is like all this. There is a bunch of signing that's happening that you are not necessarily approving.
Yeah.
But I guess the way that is being handled is the key. The key is not your key. So the key that is signing all these like state channel transitions is a key that is generated within the browser itself. So it only has access to these funds that you are like sending it. And also like, the browser is something that we consider like a trusted execution environment. It's on your client. Right. You have to like trust that everything on that browser client is happening.
Is it
can't, it's not like it's sending it somewhere else and doing it. It's doing it all in the browser.
pretty much same security concern as just using meta transaction, because meta transaction is kind of something similar that you extract, doing so that you don't have to do signing all the time. So
Yeah, that's very
whoever
true.
does the meta transaction code could do something same thing. So you're not introducing anything new. This is kind of,
Exactly.
you're doing meta transaction with state
Sending
channel.
it somewhere like to some cloud service or something. Everything is happening within the browser, local to the browser. There's nothing that's happening like asymmetrically. So
Yeah.
everything that the router signs, the browser has a signed copy of it. And that's how state channel security essentially works, is you have a copy of your state, they have a copy of their state. If any of you lose your state, like, you give all the leverage to the other person. They can dispute with whatever state they want. So it's very important to have your state in your browser or backed up somewhere. And that gets into a whole nother like topic about watchtowers and things like that.
It's a kind of hidden burner wallet, I would say.
Yeah, it is.
I think you just need to be careful with some browsers. I think Safari or so does automatically drop local server. I'm not sure, but that's maybe something to be careful about.
So we do have warnings about like incognito mode and things like that. But we've also implemented like a recovery mechanism, so you can recover. You have to trust the router to recover your proper states. But you, in the worst case scenario, the router has a copy and the router will give you a copy if you lose yours.
Yeah. So one thing is like I do actually have the kind of not escape patch, but like I can actually check the Bob's state. So if anything left over, because currently like I keep sending to transfer, but it's something got stuck. So you need to withdraw. In that case, I can actually check the state and then I can withdraw. So if I do withdraw button, I should get the money back. So there are certain things you can recover. And because it's stopped halfway, but the reverse is kind of same thing. That like you kind of
And if I can explain like where exactly it stopped, hold on, let me turn on this annotation here so I can draw a little bit. But basically here to here is where it stopped because there wasn't like a fee. So then what the router did is router said, okay, I can't forward your transfer, so I'm just gonna cancel the transfer and then I'm gonna send you your funds back. So then now your funds are sitting here in the channel. So then when you withdraw, it'll withdraw basically back to Bob, directly back to your signer address on Matic.
Oh, so it never stuck on the other end?
No, it never got to the other end if it got stuck where I'm saying it got stuck.
But for example, if you cross it, then I'm trying to swap from USDT back to USDC. But if this fails for whatever the reason, where does it sit?
So if you're trying to swap from USDT back to USDC, so you mean in this
on like, BSC, yeah.
So actually, because since it was like a withdraw issue here, so then here you tell the router you want to withdraw, then the router says, I'm not going to accept your withdrawal because you don't have enough fees. Then it's going to cancel your withdrawal. So then you have the funds still back here, and then you can withdraw the funds from here back to Bob here. So
okay, but like so do you get the money in BSC or Matic?
If it's on the BSC side, you'll get it on BSC.
I see. Interesting. Yeah.
So I mean, of course, you can always do another thing where then you write another conditional transfer back here.
Yeah.
That's extra.
Yeah. Because one thing interesting is like when it gets like that, you are in the state that you only have a token, but you don't have X to pay the gas, right?
Right.
Yeah, exactly. But I think one interesting thing is like you can go like keep doing back and forth. So in this scenario, my kind of journey ended on the other end. But if you are primarily using Matic, you can actually put the money back, then ends. So you can basically interact with Pancake without not having BNB token at all.
Yeah,
which is quite interesting. That like this one I use it for the arbitrage, but I was talking to Raul about potentially using it for kickback. That actually, if I kind of modify my smart contract to let anyone wants to stake on behalf of attendee, I could actually say that, hey, you can RSVP to XDAI kickback from Matic as well by using whatever the token they have. And they don't have to have XDAI, no other token for staking. That like when you RSVP, let's say you have a BNP token, you just deposit it. As long as that's the amount is equivalent to the XDAI amount, you first deposit in this Bob cross it to XDAI, then they hit the if it's in BNB, because BNB won't exist in the XDAI AMM, probably you first deposit on the BNB and you use Pancake to swap BNB to XDAI, then transfer it to XDAI, then you stake that kind of stuff.
Right,
so
exactly.
So this is a new way of the. Yeah, I think this is the whole new pattern. I think that's where I got very excited that this could become the new pattern of the, cross-chain kind of unified way that it doesn't really matter where it sets, because you can just like go back and forth, which is, I think meta transaction came and got a bit of buzz, but it kind of died down when the once gas price got too much. But I think this is kind of layer meta transaction plus this cross-chain bridge capability is, I think, something very unique to just using bridge. So that's something I think I'm quite excited.
Yeah, totally. Like you told me that today about like the kickback on, Matic or whatever. And that's totally absolutely right. Like you just write a withdrawal helper and then it doesn't matter. You can interact from whatever chain you're on as long as you can transfer to that chain. As long as there's a router willing to provide the liquidity to swap, that's it. And on layer 2, like the other thing is, so we have this concept of fees for the router. So the router essentially can do these transactions for free. So it'll just charge a fee. So it becomes essentially profitable to run a layer 2 router.
So that's a final question I wanted to ask is, what's your plan to always have enough liquidity that, like, this one is only $5, right? So you can't really transfer more than that. But what's your plan for having liquidity all the time, like abundance of it?
Yeah, I mean, the fees was the first step towards that. Fees literally just got rolled out this week. So we have been beta testing that with some partners. So once fees incentivize people to like run these layer 2 routers and put in some liquidity, and then if they can see that they are making profit, other people will jump in and start running these layer 2 routers as well. And then of course the network liquidity is another big thing. Like we need a way to, then you have this problem where you have like all these routers supporting different chains. And we have some really interesting ideas of how to like network the router. So it doesn't matter what chains they support. You can end up kind of having like almost like a roll up between the routers that will allow like an entry router to swap to an exit router. And it doesn't matter what's in between as long as you have the entry and the exit.
And do you have a way to separate like a kind of node operator who need a DevOps skill and just liquidity provider?
We do not right now.
Right, because that's a quite big challenge. I do.
Yeah, it's a big challenge because the fact is that the liquidity is not in a contract. It's literally in Alice's signer, like private key, because Alice needs to be able to deposit funds at the time of the transfer or before the transfer into the channel. Because there's a channel for each user, right? Each user has their own multi-sig here. So each person that wants to swap, Alice needs to like make an on-chain transaction into that multi-sig.
So that's another thing, a security concern, that it's always on the hot wallet.
Yeah, it's in a hot wallet. I mean, this is also how like Lightning Network works. This is kind of just a problem that we have to deal with right now, and we have some ideas, but this is an area of research, and I think we have some ideas that are very promising to solve this that are kind of only possible because of this layer 2 network ability.
Cool. So I think I bombarded with questions. Are there any other? I'll stop sharing. Are there any other questions? Great talks, guy. Jump off. See ya. Any other questions?
Yeah.
Yeah, go on.
Is it already possible to run such a router?
Yes, of course. If you're interested in running a router, please let me know. We'll connect later. We are onboarding router operators right now, and we have multiple like projects in the pipeline that need routers. So, yeah.
Yeah.
Okay.
One thing interesting about this arbitrage thing is like a route that probably don't need lots of deposit because it's always going kind of same amount, and they only like, you know, like 5-10% fluctuation. So I don't have to have millions, I think.
Exactly.
Yeah, so it could be easy one. I actually tried to do route the server side fast. I tried to create a bot fast, and I gave up due to my lack of DevOps skill. And so I started doing the browser side.
Yeah, I mean, we're trying to make the process easy as possible. We're close to having it just like a Docker compose file that you just run, and then it should just work.
Yeah.
So
I think Christopher commented, you could write some IAC thing with Ansible to make this setup easier, I guess. So user with not a lot of experience can spin up a router with limited knowledge about server.
oh, that's a great idea. We actually recently hired a DevOps person who is focusing on this whole router experience. So I will pass that information to them.
Cool. Anything else? Okay. So for the kickback, actually, like 13 people attended, so it's only 2. So like we'll split in 20 die among
Nice.
13 people. But hope you guys enjoyed, and I think I took video. So if it didn't break, I'll try to share on the YouTube and all that stuff. And yeah, if there's any new topic you want to talk about, you know, probably most of you guys already joined the Telegram channel. If it's not, please do join, which is in the page description page. And if you did a new hack, or like, you know, if you want to bring someone to talk about something, please yeah, propose. That's it. Okay, thank you guys.
Thank you, everyone.
Yeah,
Thank you.
Thanks so much. Bye-bye.
Bye.
Bye-bye.
But
See ya.